All right, this is lesson 1.3 or 1.3, solving equations with variables on both sides. Here's your warm-up. Go ahead and copy the problems down. This is a review of what we did in lesson 1.2c with distribution, and then come on back and we'll talk about the answers. All right, go ahead and check your work. The biggest thing I want to point out is in problem number 2, where I have this negative, I had a negative sign out here, and so I had to add that -1 out front. Be careful when you're distributing that through. A -1 times a +4 is a -4, and -1 times +1 gives me that -1. So be real careful with those signs. All right, there's your lesson for your table of contents and your objective. All right, go ahead and pause the video and write the steps for solving in your notes so that you have them as a reference when you start solving equations on your own. All right, first example. So I want to talk about the lesson title is solving equations with variables on both sides. So up until this point, we have not seen letters on both sides of the equation. We've only had them on one side. So our goal here is to collect all of the variable terms, or all the things with the letters in them, on one side of the equation, preferably the left side. That's what I would choose. So, and that'll come in handy when we start doing inequalities, and you'll understand when we get to that. All right, so I'm going to go ahead and draw a line, and I see on my left side of my equation, all I have is a 9y. There's really nothing else I can do with that. On my right side of my equation, I see a 6y and a 24. Well, my goal is to get all my y's on the left side, which means this 6y right here has to go. I have to get rid of that 6y. So since that 6y is currently positive, I don't see a negative in front there, that means I'm going to have to subtract 6y from both sides to make that go away. All right, simple subtraction. 9y minus 6y gives me 3y. And these, of course, will cancel because 6y minus 6y is 0. And then I have this 24 here that's still there, so that's going to come down. All right, 3y equals 24. Now I have to divide by 3. And those 3's will cancel. Y is going to be equal to 8. Again, if you want to check your answer, let's go ahead and write it here. Y equals 8. If you want to check your answer, you can plug it back into the equation and see if it comes out to be true. So let's try and plug let's go ahead and plug in 8 here. So 9 times 8 equals 6 times 8 plus 24. Well, 9 times 8 is 72. 6 times 8 is 48. Plus 24, so let's go over here. 48 plus 24 is 8 plus 4 is 12, carry the 1. It is 72, so it checks out. All right, so that's a way that you can check and see if your answers are correct. All right, let's see, my next problem, very similar. I draw my line. Again, I want to get all my x's on the left. So looking at this side of the equation, I see only x's, so I'm perfectly fine with that. That's what I want. I want x's on the left. Looking at this side, I see one term with an x and one without an x. So that means that the one with an x is going to have to get over to the left side with the other x's. So since this guy is a -3, that means I'm going to have to add 3x to both sides. Always do the opposite. 2x plus 3x gives me 5x. And of course, these guys are going to cancel, leaving me with -55. Be careful with that. That negative travels with the 55. Okay, so they have to stay together. All right, now I'm going to divide both sides by 5. These will cancel, leaving me x equals -11. All right, let's try another one. 4x equals negative 28 plus 3x. Draw your line. Again, you're getting all your x's on the left. So I have nothing but x's over here. I'm fine. I've got an x. I've got a negative 28 on the right, which can stay, but the negative 3x has to go. So because this is a negative, I'm going to do the opposite of that to both sides, and make sure you're doing it to both sides of the line. So on my left side, now I have 4x plus 3x, which is 7x, equals negative 28, because these guys are going to cancel. All right, that's going to leave me with having to divide both sides by 7, because I want to get the x by itself. So x is going to be equal to negative 4. All right. Okay, looks like it's a little bit harder, but it's no big deal. I can handle it. So I'm going to start by drawing my line down my equal sign like I always do. Okay, keep in mind you're getting all your x's on the left and all your no x's on the right. So looking at this side of the equation, I see one thing with an x in it, which is fine. That can stay there because my x's are going to stay on the right or on the left side. This guy, though, does not have an x, which means I have to get rid of that positive 7. It doesn't belong there, so I'm going to do the opposite of positive or opposite of add, which is subtract, which means I'm going to subtract 7 from both sides. Now, when you do this, make sure that you're lining up your numbers with your numbers. Don't write the negative 7x or negative 7 under here, under your 2x, because then you will try to add them or subtract them in this case, and they do not go together. They're not like terms. So let's do that again real quick here. I was getting kind of messy, so I'm going to start over. All right, so I'm going to subtract 7 from both sides, which is going to make these guys cancel out, leaving me with 5x equals 2x minus 21. Again, trying to get all my x's over here. So since I have a 2x, this guy is over here. It doesn't belong there. It belongs over here with the x's, so I have to get rid of that. So I'm going to subtract 2x from both sides. So 5x minus 2x gives me 3x, negative 21. And then, of course, I'm going to have to divide both sides by 3. And these 3's will cancel, leaving me x equals negative 7. All right, go ahead and try these couple of examples on your own, and then when you come back, you'll be able to check your work. All right, go ahead and check your work. Make sure you got the right answers. What I want to point out here is that on my first problem here on the left side, notice what I subtracted my x's first, okay? But on my problem on the right side, I did something different. I subtracted 10 first. I want to point out that it doesn't matter what you do first. You can either move your x's first or you can move your numbers first. For example, in this problem right here, I moved my 10s, my negative 10s first. I subtracted 10 first, and then I subtracted 2x. I could have easily subtracted the 2x first and then done the 10 second, or negative 10 second. The order doesn't matter really. You will still end up with the same exact answer. So you get to choose which one you want to add or subtract first. Just make sure that you're getting all your x's on the left and all your non-x's on the right. All right, so here comes the fractions again. Okay, so let's try one together. First thing I'm going to do is draw my line. Again, I'm doing x's and no x's. All right, I'm gonna guess that we're gonna add and subtract our numbers first, since they don't have fractions. That looks like it's a heck of a lot easier. So the first thing I'm gonna do is I'm going to subtract 6 from both sides. That is going to leave me 2/3 x equals 1/3 x. My 9 minus 6 is plus 3. Okay, now the big challenge here is going to be to get this guy on the other side of the line. So treat it just like you would any other equation. Since that's a positive 1/3 x, I'm going to subtract 1/3 x. Same rules apply, nothing has changed. So minus 1/3 x. Now when I do, I'm going to go ahead and erase this bottom part here. 2/3 x minus 1/3 x. So 2/3 x minus 1/3 x. So 2/3 minus 1/3 actually leaves me with 1/3 x. And if you're not sure, you can put the fractions in your calculator, 2/3 minus 1/3, and that will give you 1/3, if that helps. All right, so now I am at 1/3 x equals 3, because these cancel. Okay, same as before, I want to get rid of my fraction. The only way to get rid of a fraction is to do the opposite of what you see. So 1 is being divided by 3, so instead of dividing, I'm going to multiply by 3, which means I have to multiply this side by 3. These 3's are now going to cancel, which leaves me 1x equals 9, but I really don't need that one there, so x is just going to end up being 9. Okay, let's see what this other one is under this purple spot. All right, similar problem. Draw the line. Okay, let's take care of the 10s first. So I'm going to add 10 to both sides. I think this one's going to end up being really easy. That's going to leave me with 4/9 x. That will cancel. Equals negative 5/9 x. That's also going to cancel. All right, so let's see what we can do with this. All right, I think what I'm going to do here is I'm going to, just like I would before, I'm going to add 5/9 x to both sides because I want to get all my x's on one side, and since this is a negative, I have to do the opposite of that, which is positive. So add 5/9 x. Okay, so that's going to give me 4/9 plus 5/9 is actually 9/9, which is equal to 1. So that came out kind of nice and neat. So I have 1x. Now what's going on over here? I got negative 5/9 plus 5/9. It's the same thing as I would if I had negative 2 and positive 2. When I have the same number where one's positive and one's negative, that gives me 0. So since these are 0, these are similar concept. This is also 0. And you can put it in your calculator if you're not sure. Negative 5/9 plus 5/9 in your calculator will tell you it's 0. Then I just need to divide by 1. And the 1's cancel. So x is equal to 0 divided by 1, which is 0. Okay. All right. 3 things we can walk away with are just variables on both sides, and get all variables on the left. Numbers go on right. Sorry, the pen's kind of messing up here. Numbers go on the right. And then I want to add this, use your calculator. Okay, for some reason you guys are hesitant to use it. Please use it. It's there for you. It's your tool. It's your way to find the right answer. All right, see you next time. Thanks for watching.